Hello everyone, I am Kirtan Kumar Patel. I am a fourth year computer science student, and today me and my friend Rishit would be presenting the art solution to the art gallery problem. So our group ID is 19, and so without any further ado, let me go to our project. So I would be showing you the demo of our project for two cases. One would be for 10 points that we have defined in our report, and the other sample points would be a Chavatal's form made of 18 points. So yeah. So first I'll show you the triangulation and monotone partitioning for the Chavatal's form case. Yeah. So first I'll import the relevant functions from the files where we have defined them as given in the report. And here the number of points is 18, as I told. So this is the Chavatal's form that is created. And now we'll do the monotone partitioning using the sweep line algorithm. As can be seen, 1, 2, 3, 4, there are 5 diagonals created. So it creates y monotone polygons always. Now we'll proceed to the triangulation. Here, as we can see, all the monotone polygons have been triangulated, and to differentiate the diagonals, we have plotted the triangulated diagonals as green and the monotone partition diagonals as red. Now we'll perform a three coloring. We'll make a dual graph of this and then perform three coloring to the vertices of this polygon, and then find the vertex guards using the minimum number of colors used. So as we can see, the gray lines over here, these represent the dual graph, and for each face we have represented it using the centroid for that triangle. And as before, the green diagonals represent the triangulation diagonal, and the red one represent the monotone partition diagonals. Apart from that, all the vertices have been colored using red, green, and blue dots. And as we can see, at each face of a triangle, each vertex of a triangle has different coloring, and the colors of minimum number of vertex of any color present is red. So we choose red as the guard, and all of these things are shown here in the legend itself. So that's it for the Cavatal's form case. Now I'll proceed to the sample point, to the n equals to 10 sample points that we have given in our report. So yeah. So again, I'll rerun the cells. Here we have n equals to 10. So yeah, first I ran so this is the polygon. And after that, I ran the monotone partitioning code. And so we have 3 monotone partitions as seen here. Now I'll perform the triangulation. So as can be clearly seen, we have clearly distinguished the triangulation diagonal and the monotone partition diagonals. Now I'll run the 3 coloring code and the guard to determine the guards. So here also, as we can see, this represents the gray line represents the dual graph, and all the vertices have been colored using red, green, and blue. And again, we choose the red vertices as the guard vertices because those appear the minimum number of times, that is 3. So yeah, that's it from my side. Now I'll hand over to Rishit. He would continue with further cases so that So you can continue, Richard.
Yeah. Hi guys. So I'll be showing another case where we would be taking 26 sample points, and then I would be also generating a random polygon. So yeah, this is for 26 points. It's a sample case which we have taken. Here is the polygon which has been plotted. Then we do the monotone partitioning for this, and this is the result obtained. There are 1, 2, 3, 4, 5, and 6 diagonals added here. The legend also mentions the monotone partition diagonals. Then we will do the triangulation for the same, and this is the result after triangulation. The dotted diagonals represent the triangulation done for each monotone polygon. So each monotone polygon will be treated separately. Finally, we'll plot the dual graph as well as the vertex guards. The vertex guards over here, the green guards represent the vertex guard. They were minimum in number. They were 8 in number, basically. And the gray lines over here represent the dual graph. You can also check the three coloring for every triangle. We will be using three different colors, like here it is green, blue, red, red, green, blue, and so on for the entire polygon. Yeah. So now we will be doing another case where we will be generating random points. So in this case, I'll be uh, changing this sorted flag to false. The reason why this was true for this long is because we were actually giving the points in sorted order here. So now when we are generating random points, we need to sort it according to the slope and distance with respect to the leftmost vertex. And that is why we will be giving this flag as false. Let me enter the number of points. Let's say I'm entering 21. So the value of points after removing collinear points is 19. So what we are doing is, in case this has generated some collinear point, 3 points which are collinear, we'll be removing those points. As you can see here, we do not find any 3 points that are collinear, because when we generate random points, this is highly possible. So they're obviously redundant, and that's why we have removed that, removed those points. And this is the diagonal. This is the polygon we get after randomly generating points and plotting them. Now let's do the monotone partitioning. As you can see, we have added monotone diagonals here. 1, 2, 3, 4, 5, and 6 diagonals have been added in this case. Then we'll be performing triangulation. This triangulation is done for each monotone polygon in its, and these dotted lines over here in green represent the triangulation, and the other represent the diagonals which were represented during the monotone partition. After this, we'll be finding the dual graph as well as performing the tree coloring on that. And the minimum number of vertex guard required here is 6. These are the red guards which are shown here. So this is done after you do the tree coloring, and you find the minimum number of which color has been used. So in this case, red was used the least number of times. It can be equal as well, but let's say there were 19 guards, so it was 6, 6, and 7. So we're taking red as the minimum number of vertex guard required to cover the polygon. So yeah, this was our project on art gallery problem. Thank you.
Thank you.